And look how easy it is to use it. You want power? Just pull it, connect it to your project. I don't need it anymore. Pull it, and goes back in. I've made, from my point of view, the best power supply for makers, and I'm sharing all the files for this, as always, for free with you guys. Now, don't get me wrong, that is not the best power supply ever. It's only good for makers, and this is why. Well, that's because I did had my share of power supplies on this channel, and the last one was from Keysight, and it was very professional, heavy, but it had low noise, low ripple, very good steady output. And actually, I don't really need that, and I had to sell it, unfortunately. But you see, this is not a professional laboratory. I'm not making audio projects or very professional space engineering projects, so I don't need a very professional power supply. Most of the time, maybe 95% of my projects, they only need good voltage and good current. So I don't need a huge supply here which will bother me on my workshop table. So what I want to achieve with this is practicality. I want speed, having less wires on my table and a lot more space on my table. That's why I've designed this. Let me show you. Okay, so I power it on, and believe it or not, this can deliver almost 500 watts. And you must wonder, where is the supply? Because this is so small, it occupies almost nothing on my table, as you can see. Well, the secret is below my table. You see, I've placed everything here, including the Bluetooth module, so it won't occupy space on my table, and then I've made the wires retractable. Let me show you. First of all, the output of the supply is connected here, to this connector, and to these wires. And look how easy it is to use it. You want power? Just pull it, connect it to your project. I don't need it anymore. Pull it, and goes back in. And here I have yet another supply for USB output. This is USB Type-C, so it supports 12 volts and 5 volts. Connect it to my project, don't want it anymore. Pull it back, and with magnet it will stay there. It also has another 2 USB outputs and yet another one here. So I have a bunch of USB connectors that I connect to my project. And if those 2 wires are not enough, I have yet other connectors for banana connectors, which I can plug here, so I have almost 500 watts here as well. And if not, I have a BNC connector like the oscilloscope with the alligator clips that I can just connect in a few seconds like this. And I can connect it to the breadboard. I don't want it anymore, pull it out. And all the adjustments are made from here or from my phone or PC, because this has Wi-Fi as well. And the best of all, look how small it is. Remember, I had the Keysight supply which was even bigger than this. It was occupying here a lot of space and it was very difficult to move. It weighted more than 10 kilos. So yeah, let me show you my design. So guys, in this video I want to show you the parts that I've used, my 3D design, and by the way, you can download the schematic and the design from below for free as always. And maybe comment below if you want to support me, or even check my Patreon page. So yeah, that being said, if you want to see how I made this supply and how to use it, let's get started. What's up my friends, welcome back. So let's see how to make this design of my power supply and what we need for it. And remember, as always, I'm sharing for free the STL files for the 3D parts, the schematic and the part list below in the description. So maybe support me on Patreon, give me a like or comment below. That will help me a lot. Guys, I just received new PCBs from PCBWay, which by the way is the sponsor of this video.
My new project was requiring some flexible PCBs, and PCBWay was the right solution for that. And the order process is so simple. Just go to PCBWay.com and select flexible PCBs. Upload your Gerber files as always and select your settings directly on their website. You also have the option for rigid flex PCBs if you want, and other settings for the color, the thickness, the gold immersion, and so on. I received my PCBs in just a couple of days and they look amazing. The tracks are very small, but even so, PCBWay did a great job, and they have capabilities that go even lower than that, and you could check them on their website. So try yourself their services for flexible PCBs like mine, and like that you can complete your awesome project. And check more for other services for prototyping PCBs, automatic assembly, SMD stencil and much more on PCBWay.com.
So guys, stay tuned for these 2 PCB projects, but now we can continue with our project. Okay, so the first thing that we need is power. We need a power supply, and it's funny that we need a supply in order to make a supply. Now we are using the same word, but we are not making a fixed output switch power supply like this one. but rather a bench lab power supply with a variable output. The idea of any lab power supply is to have mains AC, in this case 220 volts, connected to a fixed output switch power supply for efficiency, and then a driver that will control the output and regulate the value. Now for the fixed output power supply, I have a bunch of them from older projects that I have laying around, but I've selected this one here. This one is of 60 volts and 6.6 amps, which is like 400 watts, which is more than enough for me for what I do. And this one cost me like $30 a few years back. By the way, for lower power, I have a bunch of supplies here. I never throw out a power supply. I store them here. These are all switched power supply. Now I have a few of them which are AC. But yeah, I gather everything here because you never know what you will use for a project. Now these are like 20 to 40 watts. But wait, this is important for when you select your power supply. In my case, I selected 60 volts and so much current because sometimes I do use more than, let's say, 24 volts, which is a very common voltage. But usually 95% of my projects require like 12 volts. And also anytime that I'm using a lot more current, like for example with motors, I use external battery packs. So I don't need a super powerful power supply. So maybe consider something smaller for less money. For example, a good way of saving money is to use old PC power supplies. Because for example, this one can deliver 600 watts. Now there is a problem, this can only deliver 12 volts, actually minus 12 volts as well if you want inverted polarity. And we have ways of hacking these power supplies for delivering more than just 12 volts, up to maybe 24 volts. But you must be careful. If the supply that you want to make is for only 12 volts, you are good to go with this. Actually, this can deliver a lot of current. But if you want more than that, if you want to hack it, you can find some ways online, which I not really recommend. But anyway, it's very easy to trick the PWM IC by changing the voltage divider of the feedback into thinking that the voltage of the output is not that high. So it will deliver more voltage, maybe up to 24 volts. But you have to have in mind that the main problem will be the capacitors, because this is designed for 12 volts. So all the output capacitors are usually rated for 16 volts. And they might explode. So you have to change all the output capacitors to 25 volts or 50 volts depending on the voltage output that you will have. But like that you will have a lot of current, and these are quite inexpensive. Actually, I got this for free because I found it on the garbage, and yeah, maybe use PC power supplies. Here I have a different one which is more compact. It's from an old server. And by the way, I'm not sure if you are a very old follower, because my first ever power supply that I have for my workshop was made with a PC power supply. It has both 12 and minus 12 volts output, 3.3 output, and then a regulator with a buck boost converter. I think it was up to 60 volts, but the current was limited to 5 amps. But yeah, that video is very, very old. I'll leave it in the description if you want to see it and see how this channel evolved. And by the way, if you don't have a PC power supply and you want to save money, you can use power supplies like this one. This cost me only $7. It's of 24 volts and 5 amps. So maybe if you don't need more than that, you can use one of these. And I think you can get maybe to $5 for one of 12 volts. Anyway, if you want to make a cheap one, use this. Okay, enough theory about power supplies. The next part that we need are the drivers that control the output. Now you could go with a simple bus and book converter, but if you also want to display and see the value of the current and voltage, it's a lot better to go on AliExpress. You'll find a lot of models like this one here. I selected this one because this can go up to 1700 watts, which is crazy, and 70 volts at the output. And this also has Bluetooth, which will come in handy in just a few moments, you will see. And also, this only cost me $26, which is not that expensive. But again, if you want something cheaper, for example, this one goes up to 120 watts, which is not that bad, and only cost me $10. By the way, this driver for power supply has its own display. You can control the voltage, the current, and more settings here. It can also work as an MPPT charger with another output and the same input. And it has a Wi-Fi connection if you want to control it from an app. And it also has a thermistor if you want to measure the temperature, with a fan here for the MOSFET or a separate fan for the power supply. It's pretty cool for only $26. Okay, so we now have the supply, the driver, and the rest are just peripherals. And I selected a bunch of them, so let me show you. Obviously, we need a switch. And the rest are selected from my experience because I know what I like on my table and what I don't like on my table. And the first thing obviously are banana connectors. Any supply should have banana connectors for banana connector wires. Then I've also selected a BNC connector, just as an oscilloscope. And that's because I frequently use this cable here, which has a BNC connector on one side and alligator clips on the other side. And I use this very much when I work with signals on the breadboard. I have my signals from the oscilloscope connected on one side, and then from a power supply I can connect this and also feed power to my breadboard. So yeah, it's very useful. This will be connected to the same banana connectors, and anytime that I use this kind of connector for supply, I can use this connector. Till now we have the variable part of the supply, but now we pass to the fixed output of 5 volts. A bunch of my projects are using USB connector, and USB works at 5 volts by default, and I can use it with Arduino or any other microcontroller, or anytime that I have a battery with a charger, I can use that, so I need a USB connector on my power supply. But remember, I don't want a bunch of wires and connectors here when I work, and that's why I found this. I love this thing. I want to include this into my power supply, embed it into it, and this is a phone charger that has a USB Type-C output, a normal USB-B output, and also a retractable wire, which is the cool part. Look, I can just pull it, use it if I want it, and if I don't want it anymore, and it will stay like that. It also has a magnetic connector, so it will stay there. Oh, and by the way, this will also be connected to this 20 cents USB connector, female USB connector, so I can have an extra USB output in case that I'm working with Arduinos or who knows. But yeah, another USB output. And finally, because I like the idea of retractable wires, and I don't want wires that will bother me while I'm working on my table, I also found this, because you see, the USB wire is quite cool, but it doesn't handle too much power. If I want to use the 400 watts of my power supply, I need way thicker wires, and this is, once again, a retractable system, just like that, but I would maybe change this wire because it's quite thick. You can change the wire because the spinning wheel inside of it is the same. I also want to just maybe back engineer this and 3D print it, so I don't have to buy it. It cost me like $9, but I think this is quite cool to have the wires pull it out of your power supply and you don't want it anymore. So maybe instead of this, just change it to banana connectors. Use it with your project, you don't want it anymore, click, and that's it. Okay, so we have everything, the connectors, everything that I want to add, and maybe we'll have some extra screws and maybe an LED to show when the power is on and stuff like that. But yeah, we'll have the part list below. And to merge everything, I've designed and 3D printed this case. Let me show you. So it has the hole for the main screen. This tube here is connected here on the bottom because this is where the retractable wire for the 400 watts will go. This is for the USB connector. This is for the BNC connector, banana connectors, the main switch, and here is where the charger will go. Now, as you can see, this has screws on the bottom because this will get screwed on my table. And that's the cool part of this project, actually. By the way, this was actually printed with glow-in-the-dark PLA. So as you can see, it's dark in here, but I can still see it. So I'll be able to see my power supply in the dark, which is also quite cool. I want this supply to occupy at least space as possible. So it will get screwed here. As you can see, it will occupy just like 5 centimeters, and all the rest, the power supply will be below. Because usually, for example, this is the case of one of my old power supplies. I don't have the Kisei supply anymore, but it was huge, massive, like it weighed like 10 kilograms. I already have the oscilloscope here. So what I want to do is to have as much free space as possible. So having a very small power supply, which will be fixed in place there and just pull wires, it will be the cool part. So that's why we have screw holes here and also 2 screws for the retractable wire and for the rest of the supply wire. So all these parts will be below. And not just that, but since I have Wi-Fi with this, I can control it for maybe from 2 meters away, just using my smartphone, and I can just pull the wires, connect it to my project, control the voltage, and then release the wires. I don't need a huge power supply that will occupy space on my table. Remember that I've already made holes in my table, so the wires will be below, so I don't have loose wires here on my table, for example, for the soldering iron. And also, the plugs are flat. You can just change close like that, so I don't have anything on my table. The cleaner it is, the better. And the connections are also below, so download the schematic and make the same connections if you want. And make sure that you will insulate the 230 volts, the high voltage, from the rest of them, because the main switch will be connected to high voltage that will go to the supply, and the rest are low DC voltage, so you don't have to worry about that. But make sure that you use good insulation, especially for the main switch. Okay, the next step is not mandatory. As you can see, I've opened the retractable wire system because I want to see inside and maybe make a 3D printed one, but that's not what I'm doing. I will just take out this wire. As you can see, it's quite stiff and it's also like rectangular. I want a circular one, and also it's a lot more flexible, more conductivity, and in that way it will exit a lot easier here because this one is quite stiff and strong. So yeah, I will just swipe it, but this is not mandatory. If you don't want to change the wire, you don't have to. I was just making the connections inside, and I've just opened the retractable USB cable, and I thought it should be interesting to record it and see what we have inside because this is quite small. So this is just a normal charger with a little bit more power than usual, up to 60 watts for the USB Type-C. And then we have here a 4 connection because this is a normal USB connector. As you can see, it has a data as well, which is quite interesting because why would you want a charger with data? Maybe to just read the power, or I'm not sure. We have an IC here, and look how small this is. I would like to 3D print such a compact design for the retractable cable. And as you can see, it's quite nice. And we have this pin here which allows you to stop and then retract the wire. As you can see, now it's stopped. Pull once again, it will get all inside. Okay, now I have everything wired inside here. I've also opened this and connected to the transformer, the 5 volts for the USB connector. Everything is in place and I have all the wires here, and now I've marked it on my table. I'll make some holes and the power supply and the rest will be screwed on below the table. Okay, so finally the supply is on the table, fixed in place, and now I'll show you what I have below. Okay, I first wanted to add a supply here, but then I realized that this retractable wire won't fit on the wall because in that way it goes straight up. So now I hooked the supply here with some screws. This is the main wire that delivers power here, and then the entire supply is connected here. And I have a bunch of wires which are quite well insulated, but I also want to design a case and fit it here. But for now, this is what I have: the supply, the driver, and the retractable wire, and that everything goes up here. Okay, so now let's turn it on. Switch it here, press the button, and there you have it. Now I can just turn on 10 volts. I will have 10 volts here with this cable, 10 volts here and 10 volts here. Then I have 5 volts here, 5 volts here, and 5 volts on these two. USB Type-C. It will get back. The other connector I told you is the BNC connector for like the oscilloscope, and I use it because I want it because it's very easy to use. I have the alligator clips connected to my breadboard, just hook it here, and now I will have power. And if I don't want it anymore, unhook it, and that's it. By the way, the BNC connector is not rated for high current, so I won't use it for power projects. For that, I have the banana connectors. I will just use it for signals when I'm working on a breadboard with op amps, with signals from the oscilloscope. So yeah, don't use it with high current. And I have a bunch of other connectors. For example, these kind of connectors for batteries are very common to have. So maybe I'll also add this on the side because this also has battery charger with an MPPT controller and stuff like that. So maybe add this on the side and have it to connect to charge my LiPo batteries for the RC planes and so on. So guys, I'm more than happy with the results. Look how small it is. Just to compare, this is the supply that I had before the Keysight, and the Keysight supply was even bigger and heavier. Look how much space it takes, and the difference is that now I have it like that. Everything is organized, and all I have to do if I need power is to pull this wire and connect it to my breadboard. And in just a few seconds, I have power, and if I don't want it anymore, disconnect it and pull it back in. And that's it. Very easy to use. And if I need multiple outputs for banana connectors, this BNC connector has output for banana connectors. So I would plug it here, and in that way I have one output there and another one with this one, just in case I need the double supply for my projects. Now I would like to have double output, not just one, for example 12 volts and 5 volts at the same time with high current, but that will be for another update. One last thing that I will add to my supply, I've just decided, is that I sometimes use this cordless soldering iron, and the battery here is very small, so it will give you like 20 minutes of power. So if I can reach with my cables, for example, I want to solder something here on this other table, I want to have this all the time charged. So I will add a USB output here. So as you can see, this has a USB input here. So it will stay like this here. In that way, it will always be charged. So I can have my soldering iron all around my workshop without worrying that it will get discharged. So guys, that's how I made my power supply. Now, during the make of this project, I've already think of a lot of other ideas, so for sure I'll make an improved and updated version. And also sorry if I made this video too long. Recording videos on the go sometimes without a script makes the video long, so sometimes I repeat myself. Sorry for that. If you want to just skip that part, just download a schematic and the still files from below and make it yourself without even watching the video. Yep, I hope you like it. I hope that you think it's interesting. And maybe you have learned something new, which is the most important part of my videos. And if so, maybe comment below to support my channel, or maybe even check my Patreon page. That being said, keep up.
Hey guys, so as you all know, making these kind of videos is not that easy for me. It requires a lot of time, a lot of machinery, and also oscilloscopes, power supplies, and so on, and also a lot of modules. And thanks to your support on Patreon, it's a lot easier for me to buy those modules. So thank you very much to all my patrons, and also to you guys for commenting below, for giving likes to my videos, and also sharing my videos to help spread out this information. So thank you very much.